Okay, so this man's name is Farmer Joe. He needs help building an enclosure for his sheep. We have 200 yards of fencing to build the enclosure with the most area. Each length this way is a value of y, and each half of the enclosure is a value of x. So, first off, we need to find two formulas. The formula for area, which is base times height, which is 2xy. Because there are two x's, you need to add them together, so 2x times y equals area. That equals area. Next, we need to find the equation for perimeter. Now, the perimeter is a little confusing because we have this divider in the middle, so you can't just take y and y. You have to take 1, 2, 3 y's. So, 3y, right? But we have these two x's, so we need 1, 2, 3, 4 because there are 4 sections of x, plus 4x equals perimeter. And since we know we only have 200 yards of fencing, that becomes our perimeter value, so that equals 200. So now, we need to take this equation and solve it for a variable. I'm going to choose x because I found out that's easier. So if we have 200 equals 3y plus 4x, I'm going to subtract the 3y, which would be 200 minus 3y equals 4x, and then I'm going to divide by 4, which would be 200 minus 3y, equals x, or actually you have to divide by 4 too. Can't forget about that. So that's our value for x. Now what we're going to do is we're going to take this equation that's equal to x, and we're going to plug it into the area equation, so we're only left with one variable, y. So, area, we're going to start over here then. Area is equal to, and I'm going to switch colors, because you know, it's getting kind of boring. So, it's orange now. So area equals 2y, and then we're going to replace this x with the equation 200 minus 3y over 4. I'm going to simplify that, so it is 400y over 4 minus 6, going a little crazy, okay, 6y squared over 4. And we can simplify that to 100y minus 3 over 2y squared equals area. So now that we have our equation for a with only one variable in it, we're going to take the derivative. I'm going to switch colors again. Green. Okay, so the derivative of a, which I'm sure you all know how to find, is 100, because when you have only one variable without a power to the first power, that is going to equal the constant in front of it. So 100 minus, then we have this 2 up here, so it's going to come down, that's going to be, well, these actually cancel out, so it's going to be 3y. This is our derivative. What we're going to do with this derivative is we are going to find the critical numbers, if I remember correctly. Yes we are. Okay, to find critical numbers, you set the derivative equation equal to 0. And critical numbers are where the graph of the equation changes direction. So like, it's going like this. This would be a critical number, this would be 1, this would be 1. Okay, so what we're going to do is set it equal to 0, so 0 equals 100 minus 3y. We're going to solve for y, so that would be negative 100 equals negative 3y. Get rid of the negatives divided by 3 is equal to y equals 33.3 repeating. Cool. So we just found y. Now what we're going to do is we are going to find x. I'm going to switch colors again. I'm going to black this time. Classy. So we have y. And now we need to find x. So what we're going to do is we're going to plug this y into the perimeter equation, because then we'll just be left with the x variable. So, we write it out again. 200 yards of fencing is equal to 3 times 33.3 repeating plus 4x. Okie dokie then. So we know that this is obviously 100 because we just did the reverse of that back here, plus 4x equals 200. Perfect. So what we're going to do now is subtract the 100, so that 200 becomes 100 equals 4x, and then we all know 100 divided by 4 is complicated. 25 equals x. So there you have it. For this man's Farmer Joe's field, we have 200 yards of fencing to find the greatest area. X is equal to 25 and y is equal to 33.3 repeating. And so the dimensions would be 50, because we have the two of those, by 33.3, because you repeating. And then, oh, yards. Because we can't forget our units. Okay, so we're pretty sure this is the right answer, but we're not positive. So what you can do to test this, to make sure it is the maximum area you can get with the 200 yards of fencing, is you can use a number line. So, what you do is you draw a line. It's optional to draw 2 arrows at the edges, and you take your critical numbers, which if we remember from our equation, which you can't see because I covered it up, which is helpful of me, I know, which you remember for y was 33.333. So we're going to plot that critical number right there, because there's only one at this time. So if we go back, we can determine if this is a maximum by using the derivative equation, which is CA equals 100 minus 3y. And we can use this to determine if this is actually on a graph and it's a point like right here, if it's maximum. So what we're going to do is we are going to plug in a number that's over here, like 0, to this equation. So 100 minus 0. That's a positive number, so it's going up. Right? Right. We're going to plug in a number that's bigger than this one. Let's see. Let's go with 1,000,000. 1,000,000 times 3, 100 minus 3 million, that's negative. That's definitely negative. So it's going to go this way. Negative. Positive. Positive slope. Negative slope. Yeah, we got this. So, as you can see, at 33.333, repeating, the graph goes up and then it goes back down. That would indicate that it goes up to this point and then it goes down, right? So that's a maximum because it's the highest point between these two numbers.